Okay, so hello everyone. So today I'd like to talk about a topic that affects almost every modern software project, but often goes unnoticed. Flaky tests. These are tests that pass and fail unpredictably, and they create serious challenges in continuous integration and large-scale development environments. My poster is titled Solving Flaky Tests, Current Methods, Challenges, and Insights. So let's deep dive into problem formulation. Let's begin with the graph. This graph shows the number of Flaky test related papers published each year in major software engineering conferences. And we see that the number has been steadily increasing. As shown on the left side of the poster, Flaky tests pass or fail unpredictably even when no code changes occur. They waste CI resources, delay releases, trigger false alarms, and erode developer trust in test results. Because of this, teams lose confidence in their test suites and may even ignore failures entirely. In this project, I focused on the causes of flakiness, detection, and mitigation strategies, and the evaluation of existing solutions, while excluding topics like performance testing, security testing, and formal verification. So let's move on to literature search. What current research proposes? Now, let's look at what recent research proposes. First, the survey paper, a survey of Flaky tests, provides a comprehensive overview of Flaky test researches. It categorizes existing methods and highlights their limitations and the broad impact of non-determination of real systems. Second, Deflaker introduces a lightweight way to detect flaky tests without rerunning them. It uses coverage analysis of recent code changes, achieving high recall while avoiding the high cost of repeated execution. This system was able to uncover many previous unknown flaky tests in large CI environments. However, deflaker depends heavily on coverage information, which means it can miss flaky tests unrelated to recent code changes and may not generalize well across different CI environments. Third, the FSE 2021 paper on Android proposes event order exploration. By systematically varying Android UI and system events sequentially, it exposes flaky behaviors caused by asynchronous syllables and timing issues, cases that traditional return-based methods often miss. This method is powerful but computationally expensive, Android specific, and can still miss flakiness triggered by rare timing or device-dependent behaviors. Taken together, these studies demonstrate a wide range of techniques addressing differently aspects of flaky tests, while also recalling consistent limitations that current methods have yet to overcome. Moving on to critical analysis, strengths and weaknesses, the next section of my poster compares the strengths and weaknesses of existing approaches. First, let's start on the strength side. Uh, Repeated executions can reveal non-deterministic and timing-dependent failures. Event order exploration involves detection for asynchronous and event-driven systems. Static and dynamic analysis help uncover structural entity patterns linked to flakiness, and coverage-based techniques detect flakiness without costly returns. However, there are also clear weaknesses. Many methods are expensive because they require repeated executions. Several approaches depend heavily on the environment and break under different CI configurations. Most tools defend symptoms rather than true root causes, and mobile asynchronous or concurrently related flakiness remains extremely difficult to reproduce because of its architecture. These trade-offs show that while we have many tools, none of them fully solve the problem. So, talking about the evaluation part, what the method have in common? Across all of these methods, some common themes emerge. First, existing solutions suffer from high cost, low reproducibility, and difficulty handling distributed or asynchronous behavior. Most techniques detect flukkiness over after failures occur rather than preventing them. And repeated execution simply does not scale in modern CI systems. More promising directions include deterministic test design, stable CI environments controlling randomness, event order reasoning, and lightweight runtime signals, which could help reduce flakiness at the source rather than reacting after the fact. Most interesting insight and future outlook. Finally, I just want to talk about the most interesting takeaways is that Flaky test exposes the limit of automation itself. Concurrently, timing and environment interactions create unpredictable behavior that even sophisticated tools struggles to capture reliability. This makes flakiness not only a technical challenge but a deeper engineering problem that spans tools, infrastructure, and developer practices. The poster also highlights an emerging idea. Large language model, aka LLM, assist analysis may eventually help reason about complex flakiness patterns that traditional tools miss. While this is still early, it represents an exciting direction for future research. So, in conclusion, flaky tests remain only one of the most persistent problems in software testing. But by understanding their cause and analyzing current methods, we can still move toward the most reliable and maintainable systems. So, this is the end of my presentation, and thank you all for listening. Thank you.